All right. Good morning. Welcome back. I want to just kind of recap where we're going here. If you take a look at the schedule, if you look at the titles of the content that we've been doing before Labor Day, it was mostly about learning how to use the GeoGebra and learning how to graph and stuff like that. And then Wednesday and Friday of last week, rates of change and behavior of graphs. All we're looking at is when are graphs increasing, when are they decreasing. We did a few activities on that. We specifically talked about the average rate of change, when a graph is like a squiggly line, and we can't handle a lot of that rate of change without calculus. We go to the average rate of change, and then we did that example with the marginal cost. So we're done with section 1.3. So this is the schedule that you guys can all see on Blackboard. Notice I said, begin 1.3 quiz, continue to work on 1.3 quiz. We're done with 1.3. So if you are keeping pace, you should be done with your 1.3 quiz. You guys know the one I'm talking about on the My Open Math. Now, I want to say only one of you is actually done. And a couple of you have started and a couple of you haven't even started yet. So if you want to keep pace, I would try to keep pace because you can see where we're going here. We got 1.4 and 1.5 that we're covering all today, right? So don't let all these quizzes pile up on you in the end. So notice 1.4 is linear functions and 1.5 is the graph of linear functions. So we're specifically looking at straight lines is what we're going to do here. So I'm going to grab one textbook example, then we're going to do another video problem for you guys to think about here, and then we're going to do a Desmos activity. That's our agenda for today. And then on Wednesday, we're going to do some modeling with linear functions, and then we're going to learn how we can fit linear models to data, and we're going to do an activity, do some systems of equations, whatnot, and then our test, when is it? Not until October 4th, so we don't have a test for a while here. So that's kind of where we're going. Pay attention to that schedule. Here's the example that I would like us to work on. Now you can scratch this out on a piece of paper, or you can pull out your computer and look at it graphically if you want to open up your GeoGebra and plot something. But it's the example one that is up on the screen that I'm interested in you trying to tackle. This is right out of your textbook, by the way. We're trying to write a formula. Write a formula. Total cost, TC. If we're writing this in function notation, it would be TC of Q equals TC of Q, where TC is our dependent variable and Q is our independent variable. So you could think of TC as being the y-axis and Q being the x-axis. Once you have that equation, the last part says, what will their total cost, TC, be if they expect to sell 240 wheels? Raise your hand if you're completely done. One of you? Need a little more time? What'd you get for a total cost? If you have a total cost calculator, flag me down. See how you did. Very nice. Yep. You didn't seem very confident there.
Well, no, I didn't like my formula.
So you actually didn't write a formula. You plugged the numbers in right away, right? So it's not always going to... If I take 40 times 240, I don't get that.
Yeah.
So you just didn't write your formula out because it's not always going to be 40 and it's not always going to be 240, right? So you should always have a formula that works. So what nugget of information have you not included?
The 30,000.
Right. How's the 30,000 come into play? Is that part of the TC? Part of the total cost? So you're missing a chunk.
We're just doing the letters? Like I'm not...
Well, the first part says come up with a formula. So yeah, TC of Q equals. It's a formula. Then you're actually going to punch in the 240 wheels for part 2, right? How you guys doing over there? Dalton, no problem? What'd you get? Okay, good.
There we go.
Very nice. Very nice. Good. So remember, what's the title of the section we're talking about here? We're talking about linear equations, right? It's a straight line. And you guys learned way back in 8th grade that there's basically 2 important parts of a linear equation. There's the slope and there's the y-intercept, right? So if I think of this as y equals mx plus b, that's the form that you're probably comfortable with, right? But if we're doing function notation, instead of y, we can call it TC of q, right? Or f of x is a lot of times the letters we use, but they gave us TC and q for our variables here, okay? So the slope would be right here. And then our x variable, we're not using x, we're actually using q, right? So instead of x, I would use q. And then we have some plus b, which is where we start. Some starting point, right, on the graph. So TC of q should equal, what's our slope going to be? 40, because every set of wheels costs $40. So it's going to be 40 times q plus what? 30,000. Now, some of you struggled with that. That's 9th grade stuff, right? I know, Monday morning. Okay, but this, eventually when you get going, this should be super, super easy for you to pick up, the whole slope and the y-intercept thing. Okay, so we've got an equation where it's going to have a slope of 40 and it's going to start at 30,000. So if we were to graph that guy, it would look something like this. This would be 30,000. We would start right there, meaning if we produce 0 wheels, nothing, we're already in debt for $30,000 because it cost us $30,000 just to purchase the equipment, right? So we're already at $30,000. Now the line, is it going to go up or is it going to go down? Up with a slope of 40. So over 1, up 40, over 1, up 40, over 1, up 40, and so forth. So it's going to look something like that. Right? So the more wheels we produce, the higher the cost is going to get. Now they said what would their total cost be if you produce 240 wheels? 240 represents the Q. So the total cost of 240 would be 40 times 240. I'd pull out my calculator for that and get, what, 9,600? Plus the 30,000 it cost me to start with. So I think it's $39,600. Is that what we got? Total cost. So if I was doing this on my computer, I could actually punch in my formula that I came up with. Now remember, when you use GeoGebra, if you try to use TC and Q, your computer's not going to know what the heck you're talking about. Every single time we use GeoGebra, we need to use our independent variable as X every time. So we got to change our Q into X. So here I would go $30,000 plus 40X, not Q. Okay? And notice it gives us F of X, not TC of Q. You're just going to have to understand that. Now I can't see 30,000, so I got to scrunch this way the heck down. There's 30,000. It almost looks like a flat line, but it has a slope of 40. Looks a little better if I go like this, right? Okay. So now I can see 240. So I could use my calculator just to plug in the 240, and it was pretty fast, right? I mean, that only takes you a couple seconds. But if you want to visualize it, you could go, here's 240. Where is it going to hit the green line? Well, you could eyeball it. You can see it's a little bit less than 40,000. I could put a dot there. I could say, what happens if I want a dot at 240 is my X value, comma, F of 240? I'll let the computer do the math for me. It'll plug 240 into F. I produce that dot, and it says 240 is going to correspond to a Y value of 39,600, and I'm done. Another slick feature of GeoGebra is if you just make a new point and put that point right on the line somewhere, and then you can just grab it and drag it. Now I can calculate any amount that I want, right? If I produce 125 wheels, that's where I stopped the point on, it's going to be $35,000. I can just slide B to wherever I want. Oh, what happens if I only do 60? What happens if I do 62? $32,479, right? Comments, questions? Does the graphic version of the computer help? Does it make more sense? Some people are paper and pencil people. They can write this down, really clicks in their head. They can see the graph. Other people want to see the graph because it really helps them conceptually make sense of it. So you need to kind of determine where you fall on that. Okay, I'm going to give you a little example to watch here. Let's watch a movie. Pay attention to the movie. And then we're going to just do a little bit of problem solving. Now, before I play this movie, I want to remind us of our standards again. Obviously, standard 1, you need to make sense of this problem. What the heck is going on here? What am I trying to find? What's the information that's given to me? Stuff like that. Okay? When we reason abstractly, that's when we come up with like a formula. We use X and Y or TC and Q or something like that. We're using variables to represent our algebraic variables. You got to be able to construct a viable argument. Okay? The example I'm going to show you is not as clean cut as this. There was one correct answer for this. And if you didn't get 39,600, you got it wrong. Period. Right? Sometimes in math, it's either right or it's wrong. But the example I'm going to show you right now, you're going to find out that that's not necessarily the case. All of you are going to get different answers. Okay? Doesn't mean anybody's more right or wrong, but we got to be able to use our estimation skills, and we got to be able to construct viable arguments. We're obviously going to model with mathematics. So I'm going to show you something, and you're going to have to try to build a model. That's what we just did here. On the first part where it says write an equation or write a formula, you're building a model. Okay? Use tools strategically. You can use your computer if you want, your calculator. your GeoGebra. You can plot points. You can graph. I don't care how you do this. Attend to precision. Sometimes we want to round. Sometimes we don't want to round, right? We're going to get later on in the semester, we're going to start talking about like money and investments and rates of return. And we'll look at an example where like if you're, I don't know, if you have some retirement account and you're earning 7.9% and you round that to 8.0%, over the course of 40 years, that's going to be like hundreds of thousands of dollars. Why? Because you rounded. So there's different things about precision that we need to pay attention to, right? Look for and make use of structure. We'll see that. Repeated reasoning. Okay, I'll stop talking. Let's watch a video. Pay attention.
We will now begin awarding the Master of Laws degrees. Mariam Abadi. Bakhtiar Abdulhamidov. Anish Agarwal. Monica Francis Aguinaldo. Olufunileo Ayoka Akidosi.
That's it. Somebody tell me what's going on here. Make up a story.
Second.
Say again? Why did we just watch that video? Well, first of all, what is that a video of? What did we just witness? Graduation. Okay. At Harvard.
Is it because someone's cousin is going to graduate way down the list of people, so just timing how long it takes to get to them?
Exactly. Have you guys ever sat through a graduation of a cousin, brother, sister, somebody, and you're really only there for that one person, right? Do you care about all the other people? No. You're there for your cousin's graduation. But can you just walk in whenever you want? No, you usually have to go to the beginning of the ceremony, and you have to sit through the whole darn thing, right? And really, you're only interested in seeing your cousin walk across the stage, right? So, yeah, very good, Lexi. So, the question is then, what are we going to try to solve for here? I think you said it. Yeah, how long is this going to take, right? Like, let's say that's you waiting for your cousin to walk across the stage, and you couldn't care less about all the people in front of him. Maybe you want to take a nap, right? Maybe you want to stare at your phone. So the question is, how long is it going to take? Okay, let's watch the video one more time. You guys ready?
We will now begin awarding the Master of Laws degrees. Mariam Abadi. Bakhtiar Abdulhamidov. Anish Agarwal. Monica Francis Aguinaldo. Olufunileo Ayoka Akidosi.
Okay. First thing I want you to do is I want you to guess. Okay? I'm going to only give you about 20 seconds to think about this. How long is it going to take? So you guys saw the clock on the screen, right? What's the clock going to be at when the cousin gets announced? You have 20 seconds to write down a guess on your paper and circle it, and you cannot change it. Giving you exactly 20 seconds. Write down a guess. You got 15 seconds left. 10 seconds.
How long?
How long? What's the clock going to say when it gets to the cousin? 5 seconds. 2, 1, 0. Stop. Got a guess? Okay, somebody throw out their guess. I don't.
Seconds.
Say it again.
400 seconds.
400 seconds. Let's do it in minutes and seconds. So what would that come out to be? About 6 minutes and 40 seconds?
6 minutes and like
640, right?
Yeah.
Anybody faster than 640? You think it's going to happen faster than 6 minutes and 40 seconds? That's fast. So 6 minutes and 40 seconds is my lowest. So somebody had something a lot higher than this? Go ahead, throw it out.
And 103 minutes.
103 minutes. Is anybody longer than 103 minutes? 105 minutes. Anybody longer than 105 minutes? Is everybody in between then 6 and 105? That is an enormous gap. That's a huge gap. Okay.
52 minutes and
52 minutes, so you're in between. So as a class, we think it's going to be between this. Okay? All right. All right.
it was that far down.
Seems like they scrolled for a long time.
It seems like they scrolled for a long time. Okay. Now, in order to pull this off, is there any other information that you wish you knew?
I counted from like how long it took to say like one name to the other. I got like around like 7.
Okay. So you were already doing some math in your head. Okay. And we can watch the video again. In fact, I put it on Blackboard. So you guys can watch this video over and over and over and over again. We're going to work on this for a few minutes. Okay. Is there any other piece of information that you wish you knew?
How many
How many
people?
people are...
Yeah, how many people are ahead of them? Because was anybody trying to count as that scrolling thing went? That was pretty awful, wasn't it? Okay, I do have that information. Let me share it with you. Oops. Where am I at? Okay, here's the list. We started with Miriam Abai, right?
Oh, he's a V too.
So this is the list, and this is where we got. Okay, hang on a second. Something's wrong. Because I thought I had a different document. Hold on a second. That's not it. What is going on here? Harvard enrollment. Yeah, I thought I had it somewhere else though. Sorry. Make sure I don't accidentally reveal my solution to you guys here. I thought I had something else here. Okay.
Definitely gonna be the network.
Jamie went and counted them all for you. Here's what I found out. My cousin, Adarsh Abraham Varghese, come on, is the 156th person to get announced. He's the 156th person. Okay? Any other chunk of information that you wish you knew?
Like the exact time between.
Yeah, that I don't know. Yeah, that would be nice to know, right? Any other piece of information that you think you might want to know? I'm gonna show you a little bit more of the video. Okay? Watch this video. It's the same video, but it goes a little bit longer. So you can start doing some math work now if you want. That was a mouthful.
Fatima Monica Okuno. Sarah Elmogren. Hosanna Kwaka. Pradeep Arjan Singh. Alexei Atamanov. Athena Al. Adelaida Bhattacharya. Peter Robertson Barnett. Solanku Bayasarkar.
I'm just going to let this run. I'll play it one more time too. And I want you guys to mathematically come up with an argument. See if you can figure out, get as close as you can. When is my cousin going to get announced? That's what we're trying to figure out.
Vanessa Felix Spencer. Jared Gordon Biden. Alex Bober. Ikere Borgiani. Fatima Bakar. Jasper Boyce. Hector Cardenas Ortega. Elizabeth Mary Carter.
Still got another minute to go.
Srini Chandrasekhar. Deborah Chavez Fernandez. Chen Xiaoxiao. Chen Yinghu. Spanisa Savani. Rebecca Kamar Cohen. Luna Antoine Constantine. Jose Luis Corbalan. Virginia Cueva.
Okay. I'm going to throw this second video on Blackboard just in case you want to watch it. Otherwise, I'm going to give you a few minutes to work, and we're going to share our solutions and our arguments in a little bit here. I'll put this second video up. Just give me a second.
The cousin was 100.
Cousin was 156. Now, I'm not only looking for an answer. I'm looking for you to make an argument. You have to justify to me why your answer is what it is.
We can make new answers or we stick with that?
Don't worry about your guess.
Okay.
I want you to come up with your calculated answer, which may or may not be very close to your guess. It might be very far away from your guess. Okay? Okay, Graduation Act 2 video is now available on Blackboard if you refresh your page. So if you want to watch that second video again, you can. You can do this paper pencil. If you want to use some kind of calculator or graphing like GeoGebra, you can do that. I don't care.
Is there a third video?
There's a third video, but that's the answer. And we're not going to reveal that until everybody has something. So I would say I'm going to give you about 5, 6, 7 minutes to work on this, okay? Turn your volume down if you're going to watch it. Thank you. But you're going to have to listen a little bit, right? Because you got to hear the names. I should have made everybody bring headphones today. I'm more interested in you making a good argument with mathematically sound evidence than I am you just stabbing at a solution and getting lucky. If you have a solution, flag me down. I'd like to look at it. Okay. What did you get? Okay. Anybody else? Okay.
Thomas Cohen.
Anybody else got something?
One of them turned on the volume.
Well, that's strange. Hit play once and try to do it while it's playing. I have no idea. Try. Yeah, what player are you using here? Because try doing it from get out of that and go to the speaker right there. See if you can adjust that.
This one?
Yeah. Pull that down. There. That might help. Here. So use that instead of your. I don't know what player you're running there, but normally I'd blame it on a Mac, but you have an HP, so I can't do that. You got something?
Yeah.
Well, you don't seem very confident. What's your final answer?
Just that. I just divided by 60.
I can't even read that.
52.
52 minutes? Okay.
0.1.
Okay. Anybody else got something? What do you got? Seconds or minutes?
Minutes.
Minutes.
Sorry.
Yeah, okay. What do you got? Okay. So think about the one that we just did with it cost $30,000 to get the equipment and then $40 for each set of wheels. So $30,000 was our starting point, and then every set of wheels was, one set of wheels, 40 seconds. One set of wheels, 40 seconds. One set of wheels, 40 seconds. Or $40. $40, right? Do you see a similar thing going on with the graduation video? You should, right? You should see okay, we started at some point, and if I were to graph this, it would probably be a straight line or close to a straight line. So if you're thinking linearly, you might have a y equals mx plus b type equation or relationship in your mind that might help you here. I'm going to call for answers in about 2 minutes. So you have to have something to share. Exactly 2 minutes. Okay? Okay. I have yet to see a correct answer. But that's what we expected, right? Think about it. What's the chances of you nailing this right to the second? Slim. Right. So I talked about this a little bit earlier. Sometimes in math, like the one we did earlier with the wheels, sometimes it's like all the information is there and there's one correct answer and that's it. There's no argument to be made, right? It's just computation. Sometimes there is an argument to be made and there's estimation involved. But estimation doesn't mean I'm just guessing, like pulling something off the top of my head. It's an educated guess. You have evidence to support your estimate. See the difference? Right? Okay, I think we're down to like 30 seconds here. Does anybody not have a solution written down yet? We're all ready? Okay, before we reveal the answer, I want to go with a calculated answer, so somebody throw out something for me. 26.3. Is anybody got a larger number than 26.3? Larger. 52.1. 52.1 minutes. Anybody larger than 52 minutes? So 52 minutes is our largest guess. Okay. Was anybody less than 26?
18.
18. Less than 18.
I got 15.
Less than 15. 9. Less than 9. Who said 9? 9. Less than 9. Going once? Going twice? Okay. Well, we got a little bit better, right? I was expecting this gap to be a little bit closer. That's still a really large gap, right? But doing math helped us a little bit, right? I hope you're more confident in this answer than you were in your original answer. Okay? You guys ready for the big reveal? All right. Is the excitement killing you? Here we go.
Do I have to watch
Yeah,
it?
can we fast forward?
It's gonna.
Okay.
Oh, here we go.
Get that 26.
No.
That wasn't him. Did anybody remember the name?
Argies.
There's a B in there on the K.
There was Ardash. 17 minutes and
13 seconds.
12 or 13 seconds. Yeah, okay.
I was close.
17, 13, 17, 12. Who was the closest?
I got
18 minutes. Can anybody beat 18 minutes?
Alex got 18.
You had 18 minutes as well? Anybody closer than 18 minutes?
Amanda less than.
Okay. What's that? Oh. So Matthew and Lexi, you guys win, but you win nothing. You win pride. Congratulations. Okay. I'm guessing most of you kind of went with, like, it takes about this long to say one name. Right? What would that represent in a y equals mx plus b scenario? Slope. Yeah. The slope would be the m. That's about, it takes what? How long did it take her to say every name?
About 6 or 7.
6 or 7 seconds? Do you see how if you use 6 and you use 7, you're going to get completely different answers, right? Or 6.5 or something like that. I mean, we could come up with a number for that, but it's kind of a guess. What other factors come into play here?
The
The names.
The names.
like, I feel like you get towards like T. I don't know. I feel like the last name kind of goes quicker. Like,
Well, I think where you were going is some names take forever to say, and John Smith goes like that, right? So that makes a little bit of a difference.
so like people with the last name of an I. Like, compared to,
Well, it's alphabetical.
yeah, I know.
Yep. What else could potentially come into play here?
Like they have to switch speakers or something.
Yeah, somebody could have stepped in, and they do that at some graduations. Like somebody's tired, and somebody else comes in and starts talking faster or slower.
Did that.
Yeah. Or maybe this lady just slows down or speeds up. That's possible too, right? Like, we don't know. So it's a guess, right? So I wouldn't expect you to do this per se, but I went and took every single name. I think that video showed us like 17 different names, or I took the first 17 is what I did. And I said, the first person got their name announced at 15 seconds, and the next person was 22 seconds, so there was a 7-second gap. And the next person was 28, so there was only a 6-second gap. And then the next person was 7 seconds, and the next person was 8, and the next person was 10. And I plotted out the first 17. Do those dots look like they make a straight line? It's close to a straight line, but it's not a perfectly straight line, right? And we're going to do this here coming up in the next few days. So I got what we call the line of best fit. It's the line that most resembles the dots, even though the line doesn't go through all the dots. Do you see how it misses some of them? Okay, but look at the line that I calculated. Y equals 6.74x. So what slope did I come up with? 6.74, not 6, not 7, not 6.5. I went with 6.74. So I was trying to be as precise as possible. I was trying to get as close as I possibly could. So if I went with 6.74, I ended up taking that 6.74. There it was. I just wrote down, I watched the video and I scratched this out on a piece of paper. 15 seconds, 22, 28, 35, blah, blah, blah. Okay? I got that as my best fit line. Again, we already talked about what the slope represents. What does this 9.97 seconds represent?
That's when the video starts. Like how long?
Yeah, we had 10 seconds of video before she even read off the first name, right? So think about that. What happens if we started the video from the very beginning where the president of the university says, "Good morning and welcome, everyone"? Then this would be a much larger number, and we have to go through the speeches and the songs. You guys have been to a graduation before, but that's not when the video started, right? Okay, so the cousin is 156. I plug in 156 in there. I got 17 minutes and 41 seconds. That was my calculated solution. What was the actual answer? 17:12. Am I wrong? Yeah, I got it wrong, right? Did I ever expect to get it right? No. So what I'm trying to get you to understand is that so many people think that in math it's either right or it's wrong. There's only one correct answer. Okay, we've been drilled into our head all these years of taking math class that it's either right or it's wrong. I'm trying to give you an example of how we can use sound mathematical logic and still get the wrong answer, but that's okay. I would say this is mathematically sound. Okay? Based on the information that was given to us. Okay, I want to start an activity which we may or may not get to. Go down and scroll down to on course docs and links. It says match my line. You guys see that? It's a Desmos activity. It's just going to be working with y equals mx plus b and graphing lines and understanding slope. So go ahead and jump into that. I don't know if we're going to finish in the next 6 minutes, but let's see how far we can get. If we don't finish in class, your assignment is going to be to finish this. Let's see, how many steps are there on this guy? So there's 15 steps. We won't necessarily do the extension. See if we can get through the first 14. I'll just let you go here. What we're trying to do is relate the picture of a graph to the equation of a graph and see if you can feel the relationship. Some of this might involve you counting tick marks and counting boxes on a grid to get the slope and the y-intercept. Notice on challenge number 1, which is step number 2, the idea is for it to go through both points. So one of the points is at 0, 0, and the other point is at 4, 2. So some of you don't quite have that yet. On challenge 2, all of them are supposed to go through the origin. All of them go through the origin. So if your number 2 looks like this, oops. There we go. Come on. This is acting goofy on me here. Should look like this for number 2, right? See how all of those go through the origin and each one goes through the blue dot? Not each one. One goes through the blue dot, but they all go through the origin. Okay, what I'd like you to do is finish this before you come back on Wednesday. The other thing is that's all we're doing for section 1.4 and 1.5. Now you guys have 1.4 and 1.5 quizzes to work on. When you come back on Wednesday, we're already going to be on 1.6. So you might want to, your 1.3, 1.4, 1.5 quizzes, I would strongly suggest you get going on those and at least starting them. You know, I'm not saying you got to get 100% right now. Remember, you can redo them over and over again, right? Okay, have a good one. See you on Wednesday.